employees state written exam. First question. Newton's law of gravitation applies to option A, small bodies only, option B, planets only, option C, all bodies irrespective of their size, option D, for solar system. As we know, Newton's law of gravitation can be applied to every objects in our universe. So the answer becomes option C, all bodies irrespective of their size. It is because Newton's law of gravitation can be applied to every object in our universe. A body of mass m1 is moving with a velocity v. A body of mass m1 moving with a velocity v. It collides with another body of mass m1 at rest. They get embedded at the time of collision. So that after collision, this system will become this one, m1 and m1 embedded together. The velocity of system. We have to find the velocity of the new system. The given options are option A increases, option B decreases but not zero, option C remains same, option D becomes zero. From law of conservation of linear momentum, we know that if the external force acting on a system is zero, then the linear momentum of the system remains conserved. So that initial momentum of the system is equals to final momentum of the system. So that the initial momentum of the system will be m1 into v plus m1 into 0 equal to final momentum. We have to find the velocity. Yes, the combined velocity of the system, m1 plus m1 into v. We have to find the value of this v. Okay, this becomes 0. So m1 into v equal to 2 times m1 into v. m1 m1 cancel. V equal to 2v. V is equals to v by 2. The value of the new velocity is v by 2. So the correct answer will be option D, decreases but not 0. The value of v is v by 2, which is less than the initial value. So the velocity decreases but not 0. The answer will be option B. Third question. A billiard ball moving with the speed of 80 meters per second. Collides with an identical ball at rest. If the first ball stops after collision, then the second ball will move forward with a speed of dash meter per second. We have to assume that elastic collision takes place. After collision, the system will become the given options are option A 1 meter per second, option B 16 meter per second, option C 4 meter per second and option D 8 meter per second. This question is similar with the second question. We have to use law of conservation of linear momentum. Initial momentum of the system equals with the final momentum of the system. We assume that the mass of the balls are equal to small letter m. So m into 8 plus m into 0 equal to m into 0 plus m into unknown p. 8m equal to v times m. M cancelled, so that v is equals to 8 meter per second. So the answer to this question is option D, 8 meter per second. Question. This is a very good question, so you should listen carefully. A planet is 10 times massive than Earth and its radius is 10 times smaller than Earth. Given that escape velocity from the Earth is 11 km per second, then the escape velocity from the surface of that planet would be. The given options are option A 1.1 km per second, option B 11 km per second, option C 110 km per second, and option D is 0.11 km per second. To do this question, we should know the expression for escape velocity. Escape velocity from the surface of Earth, V equal to root 2 gm by r. We know this formula from MENTORSHIP, and the value of escape velocity from Earth is given as 11 km per second. It's a given data. In our question, there is an imaginary planet. Its mass is m dash and radius is r dash. It is given that it is 10 times massive than Earth. So the value of m dash equal to 10 times mass of Earth, which is capital M. M dash equal to 10 m, and radius is 10 times smaller than Earth, so that the value of r dash become r by 10. In such a way, we can write that the value of escape velocity from the surface of this imaginary planet v e dash is equals to root 2 times gm dash by r dash. In this equation, we are going to substitute these data. So it become root of 2g into 10m by r by 10. This 10 become 10 come to the numerator. So root 2g into 100m by capital R. 100 can be take outside as 10 because square root of 100 is 10. 10 times root 2gm by r. We know that the value of root 2gm by r is 11 km per second. So 10 into 11 km per second will be the answer. The final answer become 110 km per second. So the answer to this question become option C, 110 km per second. This is a good question, so you should practice this type of questions. Fifth question. Gravitational force between two objects is F. If masses of both the objects are halved without altering the distance between them, then the gravitational force would become dash. Option A 2F, option B F, option C F by 2 and option D F by 4. We know that from Newton's universal law of gravitation, F is equal to G into m1 m2 by d square, where m1 and m2 are the masses of two objects and the d is the distance between the two objects. Here we know that the masses of the two objects are halved, so that the new force F dash is equals to G into m1 by 2 into m2 by 2 by d square. This is equals to 1 by 2 into 1 by 2 is 4, 1 by 4. 1 by 4 into G into m1 and 2 by d square, where the value of G into m1 and 2 by d square is F. So that F dash become F by 4. The new force F dash equal to F by 4. So that the answer to this question is option D, which is F by 4. Sixth question. Distance between two bodies become 6 times more than the usual distance. Then the new force become option A 1 by 36 times, option B 12 times, option C 6 times and option D is 36 times. From Newton's law of gravitation, we know that F is equal to G into m1 m2 by d square, where m1 and m2 are the masses of two objects and d is the distance between the two objects. So we have to find the new force. So F dash equal to G into m1 m2 by the distance become 6 times more than the usual distance. So the new distance become 6 times d. So F dash equal to G into m1 m2 by 6 times d whole square. So this is equals to G into m1 m2 by the square of 6 is 36. So 36 d square, 1 by 36 into G m1 m2 by d square. F dash is equals to the value of G into m1 m2 by d square is capital F. So F dash equal to 1 by 36 times F. So answer to this question become option A 1 by 36 times. This question is also semi-similar with the fifth question.